Good morning students. So today in this video we are going to discuss operational amplifiers. So regarding the content, first of all we are going to talk about operational amplifiers, then we will discuss about the circuit symbol, and then about the operational amplifier pictures, its pin diagrams. There will be some important terms, and of course we will talk about the ideal and non-ideal opamp. So let us start with the introduction. So the first term is the operational amplifier. So what is these amplifiers? So basically it is a special type of amplifier that by proper selection of its external components could be figured out for a variety of operations. Means this amplifier not just amplifies the signal, rather we can use it for different operations, like we can use it for adder, subtractor, integrator, differentiators. Let's talk about its history. So it was first developed by Johann R. Ragazine in 1947, and then in 1960 by Vidlar with the help of some IC fabrication technology. IC is here integrated circuit. And finally in 1968 Fairchild introduced the opamp that was used for the industrial purpose. So next one is, what is op-amp? Now we are going to give a basic definition to this op-amp. So it is a DC coupled high gain electronic voltage amplifier. So why it is termed as high gain? High gain means our output will be some constant factor input into its input value. That means it will amplify the input signal. And why the term here is the DC coupled? Because the supply which we are giving to this op-amp, it will be DC. So next, talking about this circuit's its symbol, that is, it has one inverting terminal, that is negative input. Other one is non-inverting terminal, that is positive input. We have plus VSS and minus VSS. So these are just the supply voltages that is just needed to trigger our op amp. So the maximum output can also go in this range, that is its maximum value will be plus VSS and its minimum value will be minus VSS. And next one is our output. So in this case our output will be proportional to the difference of two input voltage. So this is the main feature of our op-amp. Not just the output will be directly proportional to the input voltages, rather output will be directly proportional to the difference of the input voltage. So next things I have already taught. So these things we have already discussed, that what is the positive supply, we have the negative supply, we have two input terminals, and we have the output terminals. So how these op-amps looks like in laboratory, that means how we see them in our day-to-day life. So we can see these pictures here. So in the ancient times these were look like the C figure, but now we can usually see this op-amp as shown in the figure that is on the right hand side, that is it is available in the IC form. So next, talking about that IC, so it's basically its number is 741 op-amp. So how we are going to take these numbers, that is from 1 to 8, that is the where dot, here it is dot, so we will take it 1 2 3 4 5 6 7 and 8. So first one pin is the offset null. So we are going to discuss about this offset null in the next slide. The next one is the input inverting terminal, second number. Third number is non-inverting terminal. Fourth number is minus V negative, that is a power. And then is the fifth is the offset null. The sixth is output. Seventh is V plus, that is power. And the eighth is a not connected supply. So now next let us talk about some important terms and equations. So let us take A is the gain of amplifiers, VD is the difference between the voltage, V0 is the gain of voltage, and then we have the equation that is v naught is equal to a of vp minus vn. So that means gain is equal to output upon input. So we from here we have figured out the v naught. So let us talk about some important parameters, that is input bias current. So what is this input bias current? It is the average of current that flows through the inverting and non-inverting input terminals. Let us suppose in the inverting terminal the current is I1 and in the non-inverting terminal the current is I2. So this input bias current will be I1 plus I2 divided by 2. Next one is the input and output impedance. So it is a resistance that has been offered by our input and output terminals to the any kind of varying voltages. Next is the open loop gain. Open loop gain is basically the voltage gain, or we can say just an amplification. So already we had discussed about the figure about the symbol A. Next is the input offset voltage. So this was the point we were discussing in the last slide. So it is a voltage that must be applied between the two terminals of an op-amp to nullify the output. So just we have to make the output zero, or we have to balance down the output. So what should be the voltage that we are applying to the input terminal? So that is basically called as the input offset voltage, and the same is for input offset current, that the algebraic difference between the current in the inverting and non-inverting terminals is known as input offset